Hi everyone, I decided to add a voiceover to all my slides, just so that we don't have any interruptions of roommates or dogs, and I can just start over if I do. To make this presentation a little more engaging, I added images of kiddos with CP. Just be warned, they might not be directly related to the content of the slide, they're just kind of really cute. There's also a handout on Moodle to guide following along if that helps you in any way. To begin, I thought I would refresh our memory of the different types of CP that we went over in Patho. CP is a disorder of movement and posture, and it is caused by an injury to the brain while it is still developing, and a majority of those injuries occur prior to the third trimester. Because the specific location of the injury is different within each person, there are multiple types. Classification is based on quality of movements. Spastic CP is the most common, and at this point, even more so than when we were in Patho, it is self-explanatory in the name. This is primarily the type that most research is being done on. Other types include hypertonia dystonia, hyperkinetic dystonia, athetoid CP, and ataxic CP. Additionally, CP diagnoses are also determined by the limbs that are affected. Buoyancy is one of the physical properties of water which offers postural support and reduces loading on unstable joints to allow children to move more independently in water than on land. Aquatic therapy has proven to be effective in individual treatment sessions and community-based therapy programming. When I came across this evidence, I thought about when we observed at Holy Childhood during functional. During that tour, we were able to hear the OT discuss how OT and PT used the pool with some children. It is more than likely that some of those children had CP. Like many new interventions that we've learned about through these evidence presentations, aquatic therapy was shown that it should be used in conjunction with typical therapy. Biofeedback interventions are based on motor learning theory with the purpose of adding feedback via a specific sensory system. Biofeedback is any form of computerized system that provides motivation and feedback to the user. A systematic review specifically on biofeedback reviewed 57 articles and found that feedback is most effective in affecting motor performance if it is multiple modalities like audio and visual and provides knowledge of performance. Biofeedback can be used independently or in conjunction with conventional therapy. The combined method allows for varied modes and timing of feedback, as there is a difference between feedback methods of conventional therapy and computerized biofeedback. The computer gives fast visual and auditory information, while the conventional method often provides more proprioceptive and cognitive feedback. A study compared conventional therapy with the use of biofeedback, and then a combination of both. This study found that visual motor coordination and visual perception in the combination method was more effective. Motor coordination improved in all groups, and there was no statistically significant difference between the three. Overall, evidence is considered to be mixed on effectiveness due to inconsistent outcome measures used in these studies. It is also a possibility that evidence is being missed due to not using the exact phrase of biofeedback when interventions are actually using biofeedback methods. The next intervention that I want to talk about is somatosensory discrimination. The prevalence of somatosensory impairments have been reported to be more than 75% in kids with CP, especially stereognosis and proprioception. Researchers of this intervention in 2017 couldn't find any evidence-based interventions to improve somatosensory function in children with neurological impairments. They decided to use a program that already existed for a different type of impairment. Sense training was originally used for adults who survived stroke. This training involves exploration and training of occupational tasks using techniques where vision is occluded and activities are performed with either just the less affected hand or bilaterally. The outcome of this training was improvements in somatosensory discrimination, motor performance, and functional goals being attained. These outcomes made sense to me as we have discussed that in stroke survivors, prognosis is better when sensory is intact. Based on this evidence, it appears that the same is true of CP. I wanted to take a moment to discuss CP-specific evidence I came across about interventions we had already discussed. In a systematic review comparing all intervention types of CP for children 0 to 5, researchers found strong evidence that constraint-induced movement therapy showed significant improvements in upper extremity function. Time of constraint varied across the studies, I believe 3 to 6 hours a day, but improvements were still made. In a systematic review of just effectiveness of mirror therapy for kids with CP, it was found that the evidence is mixed on the effectiveness. Some studies actually found a decrease in activity of both hands, and in others it was found to be effective. This mixed evidence is likely due to the cognitive impairments that are present in 30 to 50% of individuals with CP. As we future clinicians move forward, it may be beneficial to try this intervention if there are no cognitive impairments present, as it may be motivating to a child. I also found some evidence regarding task-oriented training provided in a group setting, which intrigued me, thinking about our health policy discussions and the possible push for more groups in OT. It was found that kids with CP often have common goals, so working on these tasks together was investigated. The group using task-oriented training had significant improvements compared to those receiving individualized therapy. In addition to the gross motor and fine motor improvements, there was also social function improvements as well. So if we were to think about what the application of this evidence is for us as clinicians, many of these interventions had impacts on the whole body, not just motor performance. Often there were cognitive, visual, or social outcomes in addition to the motor reports. As future clinicians, we should be aware that many of these interventions had a motor theory basis, some even breaking down the outcomes based on the 7 principles we learned in lecture. From my research, I came across many interventions that we have discussed with other diagnoses. With clinical reasoning, don't be afraid to try them with kiddos with CP. This is somewhat of a future study piece of information, but if any of us have the chance in our future careers to do research, do more studies with adults with CP. Kids aren't tiny adults, and adults aren't large kids. I did not report on any adult-related CP evidence, but truthfully, pediatrics dominates the literature. While some individuals may have their routines and roles determined by adulthood and may not need OT, some might, and we should have the option to be evidence-based for those individuals as well.